Hi everyone. So in this video, we will be looking at rate limiting algorithms. We will be trying to implement these rate limiting algorithms and let's see how it goes. So first of all, why do we actually need these rate limiting algorithms? So basically the two major reasons are that to control the traffic that is coming onto the server. Along with that, another reason is that to prevent attacks, to prevent from the outside attack. So sometimes this can be the case where multiple requests are sent to a server so as to bring the server down to so as to slow it down for the genuine users, right? So this is something that has to be taken care of. So for these are the two very basic and very important reasons for implementing these rate limiting algorithms. So a very nice example of this is with Claude or GPT or any of such an LLM. If you try to use, then they have this rate limit where with Claude, as I've seen, for a certain time, it allows you to send certain number of requests, and after that, if you send another prompt, a message will pop up with take a subscription or something, and also along with that, the request limit has ended for you for certain amount of time, and after a certain amount of time, you can start putting those requests again, right? So this how this is done. So this is done using these rate limiting algorithms. So this is done on the basis of user token or on the basis of JWT tokens or on the basis of the cookie that helps us maintain our session. So this is what is being done using rate limiting algorithms. All of this is done using rate limiting algorithms. And our aim today is not getting deep into it, but just trying to understand this overall and trying to implement this, trying to write some code and trying to implement this, and let's see how it works. So these are a few rate limiting algorithms we'll be discussing upon on all of these. And let's start with the sliding window algorithm. So what is a sliding window rate limiting algorithm? So as the name suggests, it is something like we have a window, we have a certain limit for something, and with some condition, we try to slide that window ahead, then and so on and so forth, right? So let's try to understand this in a better way. So let's say we have a server in this case. So this is the server consisting of different more than one APIs, and this server might be interacting with many other microservices. So the major reason that we need rate limiters is that whenever there are multiple requests coming onto the server and all of these are being sent to some critical microservices, and if it goes out of hand, if this critical microservice comes down or whatever, it breaks down, it is going to create a problem, right? So we don't want that to happen. All of these critical microservices are kept behind. Also, many different load balancers like Nginx and all, you can also all of this is configured in it as well. So what we are doing here today is we are trying to just implement that, and we are just trying to go around it and trying to implement this and trying to write some code, trying to understand this, right? So um uh, so what so with sliding window, let's come to sliding window. So what happens is, so one option with limiting, so in rate limiting we have a limit. So one limit would be there, which would be, let's say, 5 for now. So we are going to allow a user to send only 5 requests. And with that, we also have a window size. So the window size, let's say, would be 60 seconds, which is 1 minute. So within a minute, a user can only send five requests. The sixth request that comes within that minute would be dropped off, and a response will not be served for that. So how can this be implemented? So one option is that you can start at different time stamps on on a real time basis. I mean, on a real time clock, say scenario. So let's say if it's 10:00 a.m. and now you will have to start from 10. So let's say this window size is 60 minutes. Okay. So considering this window size to be 60 minutes, what we have is, let's say, from 10 a.m. to 11 a.m. we have 60 minutes with us, and within those 60 minutes, only 5 requests will be served for a single user. Now, if I try to get in here, if I don't come at 10 a.m., because which will be the most possible case, I won't be coming in at 10 a.m. I will be coming at 10:15 maybe, or 10:30 maybe. So if I come in at 10:30, within that half an hour, I have only 5 limits. I have only five till 10 till 11, and then I obviously it is going to revive later on. So this is on a certain use case. So this is something, so this is some sort of a fixed bucket algorithm which we have mentioned here. We'll be discussing upon that later on. And this is something that has been implemented in Claude as well. In the behind the scenes, maybe this is something that they're implementing because it is dependent upon a certain time duration, and that time duration is dependent upon the real clock time that we have. Okay, so this is something different. But with sliding window, what it does is if you start at 10:30, if you start at 10:12, if you start at 10:15, it doesn't matter at all. Start at any time, your clock will start at that time, and that it will create a window of five, of a limit of five. So within the next 60 seconds, whatever comes in, if it satisfies the limit, if the next 4 requests will be served, so you have a request that has come up at 10:15, then your time starts now till 11:15, and the next 4 requests will be served. But if there's another sixth request that is coming up, it will not be served, right? So this is how a sliding window works. Let's try to understand in a deeper way. So let's say we have a user X, and this user X comes up at t is equal to 0. So we will be storing timestamps of this user for the request that the user is requesting. So if at t is equal to 0, we receive one request, then at t is equal to 1, we receive another request, then we receive another at t is equal to 2, then we receive at t is equal to 5. So now in this case, let's consider the window size to be 60 seconds. So at t is equal to 0, 1, 2, and 5, all of this is under 60 seconds. So initially the window was not present. So t is equal to 0 was the first thing that is coming up. So at t is equal to 0, we have our pointer, which is the starting point of our window. So this is the starting point of our window, right, at t is equal to 0. Now the next 5 requests will be solved. I mean, next 4 requests will be solved after t is equal to 0. So 0, 1 to 5 and t is equal to 10 will also be solved. Let's say if something comes up at 10. So t is equal to 10 will also be solved. But in this case, if you at t is equal to 11, or from t is equal to 10 to t is equal to 60, if you put in any other request, that will not be solved and that will be dropped off, right? So this is understood. This is the window size. Now where is the sliding part coming up? So at t is equal to 0, one request is served. At t is equal to 1, another request is served. At t is equal to 2, another request is served. But now the next request which comes up doesn't come at t is equal to 5. It comes up at t is equal to 70, t is equal to 75. So t is equal to 75 is obviously greater than 60, which means that after 2, so the sliding window starts at 0, and 0 to 60 is the window that we have. Then at t is equal to 75, another request comes up, which means that your window is t is equal to 0, 1, and 2 itself, and t is equal to 75 does not belong to this window of 0, 1, 2. It will belong to a newer window. So whenever t is equal to 75 comes up, what we do is we move this pointer to t is equal to 75. Now here the new window will start, right? So which means that we have slided this window to t is equal to 75, which is a newer element. So initially we had t is equal to 0, 1, 2 in our window. Now we have slided this window downwards, and we have t is equal to 75 in our window. So this is basically how the sliding window is going to work. Let's try to implement this. Let's see how we can understand this better by implementation. Okay. Okay, so first of all, I have a very basic basic API kind of thing. So what we have is we have a single route and it just says welcome to the application. So we are going to test with this itself. Now inside of this, I'll just create a new file, sliding window rate limiter.js, and let's declare a class in here, sliding window rate limiter, and also just export this module dot exports equals sliding window rate limiter. In this we will have a constructor where we have this dot, so we will have a maximum request limit that would be in this case 5, and also the window size. So the window size that we are implementing in this would be 60 seconds as we have discussed, so 60 into 1000 milliseconds. And then we also have a client. Okay, so why do we have a client? We need to connect to Redis. So first of all, if I go to my terminal, yeah, so the Redis is working currently, Redis is running. And so what we are going to do is we are going to store all of this into Redis, the the IP address that comes up, and the requests responding to that, corresponding to that IP address, should all everything will be stored on the Redis itself. Okay, so first of all we have a so for that we need a client, and this dot I'll set this as null initially, and let's just include const Redis equals require Redis, and I'll just in cd API npm install Redis, and once this is done, now the next part is okay. So we need functions. So first of all, we need to connect, and okay, so we will declare it as async because connection requires time, right? So first of all, we will have this dot client as Redis dot create client, and with create client we will have a host. The host would be local host, and the port would be the default port, which would be 66379. Right, so we have this client now. Now I need to connect, so I'll just say await this dot client dot connect, and then let's just console.log connected to Redis. Also, we need a function called as limit where we will write the entire logic for our sliding window. Now let's just make some changes to the app.js. So I need to call the limit function here. So first of all, let's have this sliding window rate limiter require slash sliding window rate limiter, and I need to call this sliding window. Along with that, I need to connect as well. Okay, so maybe I need a function altogether here. So if I have this function, and then let's call it here itself. So in this function, the first thing that we will be doing is we have a sliding window rate limiter, right? So let's have a rate limiter, which would be new sliding window rate limiter. Once we have this, we will say await rate limiter dot limit, and after this we need to have, okay, so this rate limiter we will be adding as a middleware to our application, so that with every request and response, uh, with every request that is coming up, all of this will be taken care of. I mean, with every request, this function will be executed, and then this middleware will come into action, and then the decision can be taken based upon that, right? So we will have an app.use. In app.use, we have a rate limiter dot limit, and also, okay, so rate limiter dot limit function will be used here. And yeah, but the thing is that this function is in this class, so we will have to bring it out, bring it out here and have to execute in the context of this. So we will use a bind function. So what this does is, for a given function, creates a bound function that has the same body as the original function, right? So we basically want to bring this function over here, and that is why we will be using this bind, because we are going to have a request and response which has to be sent from here, right? If this was a void function, it would have been a different thing, but we just bind this function here so that we can use it as a middleware in app.use, and a request response can be objects can be sent to it, right? So in async.limit, we need to have a request response in next. Okay, so now let's write the actual logic of how are we going to implement this. Okay. Okay, so the logic here starts here. So the first thing, the very first thing that we do is get the IP address. So in this case, we are only dealing with the IP address. So the first part would be to get the IP address of the user, which will be in the request body itself. So in the request object itself. So we will get the IP address. Once the IP address is obtained, the next part would be to get the queue from Redis. So from Redis, to get the queue from Redis for this IP. So for this IP address, there will be a queue which is saved, and in this queue there will be timestamps of all the requests that this IP address has requested. So that queue will be taken up from Redis. Now once we have this queue, the next thing would be to now what we have to find here is we have to find the entire window. So how are we going to find this entire window? So let's say so the limit is 5, we have 4 elements in the window itself. So now that we have these 4 elements, out of these only 2 elements are, so if we compare current time with the last 2 elements, these should fall in the window, right? So let's say currently the window is, so with every, we are not keeping a track of the index at where the window is present, right? That has to be calculated with every request that is coming up. So this request has come up. Now we need to calculate that what was the index at which the window is starting, and am I fitting into this window, or am I getting dropped off this window? So this is something that has to be taken care of now at this point. So the first thing that will be done is that we will check all the elements in the queue. So traverse along all the elements in the queue, and for all the elements, check if the difference between time and the current element current element than is less than window size. Okay. So if the difference between current time and the current element is less than window size, so current time is actual current time, and current element is the timestamp which was saved in the queue. So if that difference is less than window size, then obviously we can give access to the user. But if not, okay, so let's do this here. If it is greater than or equal to window size, okay, so this is not what we will be doing. So what we want is we need to actually get all the elements that are in a window. Okay, so what we can do is we can extract all the elements by comparing with current time if less than window size, if fits in window size, right? If fits in window size. Okay, so what we will be doing is we will traversing across all the elements. In all the elements, let's say we have these elements. So let's say we have t is equal to 0, 5, 6, 7, and 10. Okay, so let's not have 10. And the next request comes up at 11. So 11 should fit into this window. Okay, so let's do one thing. Let's have this as 65, then 66, then 67, and this is 70. So what should be done here is this 0 is of an old window, right? The window should start from 65, 66, 67. All of this should be in the window, and 70, which is coming up, should also be taken up in the window itself. Okay. So this is the window that should be obtained. So in the queue, we might have elements more than that of the window, obviously. And why is that? Because the limit is 5, so we are going to have the requests up to the limit, and then we will obviously truncate it later on, but that's a different part. So yeah, and that truncation is done only just because we don't want the storage capacity to get full. Okay. So at t is equal to 0, we had a request. Then the next request came at 65, 66, 67. So in this case, in this step, what we are going to do is extract all the elements by comparing with current time. So current time is 70. 70 minus 0 is 70, which is greater than the window size. We don't want this. We want 65, 66, and 67. So the array that we get in the result would be 65, 66, and 67. Now check if so this is the window that we have. So if window size is greater than or equal to the max window size, then drop the request. If not, then add this request to the queue. So if not, so 70 is not 70. So we have a limit of queue. So 70 will be added here, and this new request will be coming up onto the queue. And after this, what we can do is we can trim down the queue up to 5, right? Up to 5 or 4, whatever. So we can trim down rest of the queue. So, and at the end, what we will do is once we have this 0 is of no use, so we can just put it out, right? So this is how we are going to implement this. Now let's write this code. So the first step is get IP. So const IP equals rect dot IP. Now once we have the IP, get the queue from Redis for this IP. Okay, so now the next part would be const that queue would have timestamp. So let's say const timestamps equals this dot client dot L the command that we use is lrange lrange for the key as IP from 0 to all. So we need all elements. So we will say 0 to -1, and this is the timestamps that we have. We'll add an await here. Once we have the timestamps, we need to find the window. So const current window. So const current window would be uh, timestamps dot filter for t. What we will be checking is that um okay, so for t, what we'll be doing is we need to have a current timestamp as well. Okay, so const current time equals date dot now. And with this date dot now, what we will be doing is we will be checking current time minus t, and if it is less than current time minus t is less than this dot window size. Okay, so here we are dealing with this step, extract all elements by comparing with current time if it fits in window size, right? So if it is less than window size, then we are adding this to the current window array. So once we have this current window, what we will check is if current window dot length if current window dot length is greater than or equal to this dot max requests, which means that we are not going to serve any request again. So I'll just say return res dot status. Let's send status as 4 to 9 dot send, and it would be too many requests. Try again in a while. Okay. Okay, so this is how we are doing it, and at the end we also need to add this request to the queue and trim down rest of the queue. So we are going to add this request to the queue. So for that I use await this dot l push this dot client dot l push L push, it should be for IP and the current timestamp. Then we have this dot client dot L. Um, the last thing that we're doing is trim. So L trim for IP from 0 to this dot max request -1. With this, we are going to trim the window down so that all of the elements are not stored and the queue doesn't end up being a huge, very huge queue. And after this, we will be calling next because it is a middleware that we want to implement. Okay, so this limit looks fine now with app.js. It is giving some error here. Cannot read properties of undefined reading IP. So we have app.use await rate limiter dot limit. I think we have not connected here. So await rate limiter dot connect. Okay, so we have called the limit function here. Instead, it should be connect. Yeah, so now this is working. Connected to Redis, listening on port 3000. And yeah, so this is working fine. Let's try to hit on this. So I'll just say call HTTP localhost 3000. It says empty reply from server. So something is missing, something is wrong. Sliding window 30th line. So on the 30th line, it is saying current time. Okay, so if I just change this to string. If this is being stored as a string, I need to also do this as parse int of t less than this dot window size. Okay. Okay, yeah. So this is being executed. So the first request that we sent has come up here. I'll also do one thing over here after this, after pushing and trimming, I'll just console.log. I need the latest timestamp, right? So I'll just say let, then I'll say timestamps equals await this dot client dot L range of IP comma 0 comma -1 and then console dot log timestamps. Okay, so hopefully that works. We have 1 minute as the time limit. And let's see if that works. So I have two elements in the queue now, and also we need the window size. So current window dot length is the window size, and if it is not getting into the window, it should be thrown out. If it is getting into the window, then we need to print that. So okay, so these are the timestamps that we have, and console.log current window size would be window dot size. Okay, so it is current window dot length plus 1. This should be it. Okay, so the current window size is 2 because the first element that was present is of no use to us, and we have just and this is out of the window. So the window currently consists of these two elements, or the first two elements, whatever. And with the new window, yes, we have a new element. The current window size is 3, so these three elements are going to be into this. Then we have four elements now, so the current window size is 3 because maybe the first element has been out of the window now. And then we have current window size as 4. So as you can see, this 113 which was already present has been removed, and we have 63 which was the last second in the queue, and we have current window size as 5. After this, we the response that we get is too many requests, try again in a little while, and also nothing comes up here because the function returns here itself, right? So yeah, so again, welcome to the application because one of the requests might have because after a minute we might have create after a minute of the first element of the window, we might have hit this request, because of which welcome to the application, and it has given us the access. But after, as soon as I try to send another request, it is just throwing me out, right? So this is how basically we have implemented the sliding window rate limiter. So this was all about sliding window, and thank you so much.